Kubernetes is powerful, and it's changing the way applications run. But there is one problem. It is not easy. And if you're into DevOps, sooner or later, you'll have to work with Kubernetes. If you have ever tried to deploy your first application, then you might know before you can deploy. You have to understand networking, storage, manifest file, and so much more. To make things worse, everything happens in the command line. No visuals, no clear feedback, just commands, errors, and hours spent trying to figure out what went wrong. It's frustrating, and for many, it's where they give up. But what if Kubernetes didn't have to be this complicated? What if you could see everything, manage deployments, scale workloads, and monitor your cluster, all from a simple visual interface? That's where Portainer comes in. So, thanks to Portainer for sponsoring this video. It simplifies Kubernetes management by giving you a powerful, user-friendly web interface, so you can deploy applications, monitor workloads, and manage your cluster effortlessly. In this video, we'll set up Kubernetes with a single command, deploy Portainer to manage it, and then see how easily we could deploy applications, scale up, and manage nodes, all through an intuitive UI. And you can follow this process on any virtualization platform. So let's get started. If you already have Kubernetes installed and just want to deploy Portainer, you can skip ahead to the installation section. But if you need to set up Kubernetes from scratch, then create an Ubuntu server virtual machine and follow along. I've already created a Ubuntu server virtual machine and connected to it using SSH. Before we install Kubernetes, we need to perform few tasks. Disable swap, set a unique hostname, and set a static IP. First, let's update the system to ensure that everything is running on the latest versions. So I will execute sudo apt update and sudo apt upgrade-y. Once the update is complete, let's disable swap since Kubernetes doesn't work well with it. For that, I will execute sudo swapoff-a. Next, we need to modify the hostname. This step is crucial because each node in the Kubernetes cluster must have a unique hostname. To set the hostname, run the command sudo hostnamectl, set-hostname, then the preferred name. For this virtual machine, I'm going to set the hostname to node1. Now that the hostname is set, the next step is to configure a static IP address for this VM. This will help us to keep our network connection stable, especially when we are working with Kubernetes nodes. To set it, first I will look for the network configuration file by executing the command ls/etc/netplan. Don't worry if the file name looks different from mine, as it depends on the version of your operating system. Now let's modify this file. For that, we will execute sudo nano/etc/netplan/ then the file name. Inside it, you will find a line dhcp:*true. This means the system is getting its IP address dynamically from a DHCP server. But we need to set a static IP instead. So I will replace it with a manually defined network configuration where the IP address is set to 192.168.0.50. Once done, I will save the file by pressing Ctrl+X, then Y, and Enter. Now let's see if the static IP is applied correctly or not. To check, I will execute sudo netplan try. If everything works properly, the IP should be updated. Once the update is complete, we need to restart this VM and reconnect using SSH. This time I will use the static IP that I configured earlier. As you can see, the connection is successful, and the static IP is working as expected. The hostname is also updated. So let's move on to the next step. Now let's install Kubernetes on this virtual machine. So I will go to Google and search for K3s. Let's click on the first link, which is the official website. K3s is a lightweight version of Kubernetes and is mostly preferred for home labs. At the top of the page, you will find the installation command. Simply copy this code and execute it in the terminal. Kubernetes will be up and running in just a few seconds. To verify if the installation was successful, here we have another command to get the notes. Let's see if we are able to run it. We are getting an output, which means Kubernetes installation was successful. As you can see, currently there's only node 1, and it is in ready state. Now let's deploy Portainer, so that we can use a graphical interface to perform different Kubernetes tasks instead of executing commands in the terminal. So let's go to portainer.io. Portainer offers a free 3-node license for its business edition, so you can try it out at no cost. Now to deploy Portainer, we can find the instructions under Resources, then Documentation. Portainer's official website has everything well documented. If you want to set up Portainer for any other platform, you can find the instructions here. We will be installing the Portainer Business Edition. So we can find the details under Install Portainer BE for Kubernetes environment. On this page, if you scroll down, you will find a section, Deploy with YAML Manifest. Make sure this expose via node port is selected. And copy this command. In the terminal, type sudo and paste the command. Then press enter. It will take a few seconds to pull the image and deploy Portainer. Now let's try to access it through the browser. We can access Portainer using the IP address of the VM followed by colon and the port number 30777. With that, we are able to access Portainer's initial login page. If it doesn't load right away, give it a moment and then refresh the page. Sometimes it takes little time to initialize. If you want to access through HTTPS, you should be able to access it on port 30779. Let's quickly create the initial admin account by entering a username and a strong password. Then provide your license key. And we should be able to successfully log in to Portainer. Now if I click on this Get Started button, you can see it has automatically detected our local Kubernetes environment. Simply click on this local environment, and you will be taken to the dashboard page. On this page, we will notice different types of Kubernetes components. For now, we will keep it simple and focus only on deploying an application. With Portainer, this is really easy. Just a few clicks and our application will be ready. So let's see how we can do it. I will navigate to the Applications section. Now there's two options to create an application. We can either use a form or directly write the Kubernetes YAML configuration in the UI by clicking on Create from Code button. Although Kubernetes offers multiple ways to deploy an application, but the most common way is to use a manifest file. I'm going to deploy Nginx web server. And this is the manifest file for it. This looks complex, right? Don't worry. Portainer's GUI makes this really simple. I'll cover deploying using a manifest file or GitOps in a future video. For now, instead of using the manifest file, we will be using a form. So let's click on the Add with Form button. Here, I will provide the service name as Nginx-deployment and set the image as Nginx. Then scroll down a bit until you find the section Publishing the application. We need to select the node port services and click on the Create Service button. By default, Nginx uses port 80 for HTTP requests, so I will set the container port to 80 and the service port to 80 as well. For the node port, I will enter 30080. Once done, we need to click on the Deploy Application button. As you can see, the initial status shows replicated 0/1, which means it's not yet ready. Let's refresh the page. Once the deployment is successful, Portainer will update the status to replicated 1/1, and you'll see a green dot next to it, indicating everything is running smoothly. Now if I click on this application, we can see all its details. And there's a section for application containers where we can see all the available pods details, including name, image, status, node, pod IP, and more. But that's not all. Portainer also gives us some really useful management tools right here. We can check live stats to monitor resource usage, view container logs through the web UI, and access the container console directly by clicking on the Connect button. Additionally, we can execute commands within the console and disconnect easily when needed. Now, to access the service, we can simply enter the node port along with the IP address in the browser. But instead of manually typing the URL every time, let's configure a public IP. To do that, I will navigate to Environment-Related section, then to Environment, then go to Local. Here, enter the IP address where Portainer is running in this public IP field, and click on the Update Environment button. Now if I go back to the applications, we have a link here. Just click on it, and we are able to access Nginx web server successfully. Now imagine this Nginx server as our web service, which is currently deployed on Node 1. If we check the cluster details, we can see that Node 1 has limited resources, which is sufficient for now. But what if suddenly traffic increases in production? A single node won't be able to handle the load. It will start dropping requests, leading to a slow and unresponsive website. And obviously, we don't want that. This is where Kubernetes shows its actual capability. We can add multiple nodes to a same cluster and distribute the workload. So let's see how we can add another node to this Kubernetes cluster. I have created another Ubuntu server VM. Similarly, updated the system, disabled swap, and updated the host name. As we need a unique host name, so this time I will set the name as Node 2. Also, we need another static IP for this VM. I will set it to 192.168.0.51. Once done, let's reboot the VM and connect back to it via SSH using the newly assigned static IP address. The VM is now fully configured and ready to join our existing Kubernetes cluster. But before installing Kubernetes on Node 2, we need to extract the K3s token from Node 1. So let's go back to K3s official website and click on Refer to the docs. Then navigate to Quick Start Guide from the left side menu. Here, we will find a command to add an agent node. But to run this command, we need the node token and IP address of Node 1, as it serves as the control plane of the cluster. Now if you look closely, there is a file path mentioned here, where the node token is stored. Just copy this file path and add sudocat before it. Then execute the command in the Node 1's terminal. This will display the node token. Make sure to note it down somewhere. Once you have the details, replace my node token with extracted token in this command, and my server with the IP address of Node 1. So let's execute the command inside Node 2. As you can see, K3s is now installed successfully on Node 2. After refreshing the page, we can see it has joined our existing cluster as a worker node. And if you notice, available resources is displaying the combined resources of Node 1 and Node 2, which means we can distribute the workload among both the nodes. Since Node 1 serves as the control plane, it will handle scheduling pods to a node. Now let's expand our cluster by adding a new node, just as we did for Node 2. The 3-node cluster is idle for most scenarios to achieve high availability. This is another VM which I have already created. We need to perform the exact same steps we did for Node 1 and Node 2. I will just set the host name to Node 3. For the static IP address, I will set it as 192.168.0.52. Once done, let's add this node to the existing Kubernetes cluster. So I will execute the same command which we prepared with K3s token and IP address of Node 1. Once K3s is installed, Node 3 should be added to our cluster as a worker node. Also, the available resources should be increased to the combined resources of all 3 nodes. So now that we have 3 nodes, whatever pod we deploy in this cluster, Kubernetes will decide and schedule it to a node automatically. And we can also achieve high availability, which means we can distribute the same service across multiple nodes. This way, if one node goes down, another can take over. So let's see how we can achieve high availability. I will go back to Applications and open Nginx deployment. Now, to make our service highly available, we need multiple replicas of the pod. So let's edit this application using this Edit Application button. Then scroll down until you find instance count, which is currently set to 1. If we increase this number, Kubernetes will scale up this application in no time. So let's set it to 2. Once done, click on Update Application and then Confirm. As soon as we update the application, you will see another pod starting up with a waiting status. Now if we check the Applications page, we will see that the status of Nginx deployment is green and showing replicated 2 out of 2, meaning both pods are up and running. This means Kubernetes will always try to maintain 2 running pods for the Nginx deployment. On Application Details page, we can see that these 2 replicas are running on Node 1 and Node 2. Now, if one of the nodes goes down, the other one will keep the service running, ensuring there's no downtime. At the same time, it's really easy to start the same service on another node. To understand this, let me create a similar scenario. I will go to Cluster and then Details. Then if we go to Node 2, here you will see an option for availability, which is currently active. But if we change this option to Drain, the control plane will no longer schedule any pods on this node. So let's click on Update Node and confirm it. Now, if we go back to Details, we can see that Node 2 is still marked as ready, but it's showing Scheduling Disabled. This means Kubernetes won't schedule any pods on this node for now. So let's check what's going on with the pods. I will go back to Applications, then Nginx Deployment. Here we can see that the pods are running on Node 1 and Node 2. Since we have set Node 2's availability to Drain, no new pods will be scheduled on it. So let's click on the Redeploy button and confirm the action. Now, if we reload the page, you'll see that the pod on Node 2 has been migrated to Node 3. I'm just creating a scenario where pods won't be assigned to a specific node. That's why we are manually redeploying the application. But if the node actually goes down, Kubernetes will automatically migrate the pods between the available nodes. But what if even Node 3 goes down? Then how will Kubernetes still run 2 instances of this application? Let's drain Node 3 similarly as we did for Node 2, so that we can check what actually happens to the pods. So let's go back to Cluster and then Details. This time we will first go to Node 2. This is necessary because, as you can see from this message, we can't drain 2 nodes at the same time. So we will change its availability to pause and update the node. Now let's go to Node 3 and set the availability to Drain. Then click on Update Node and confirm the action. Let's redeploy the application once again. Here, you can see both the pods are migrated to Node 1. This might not be very effective because if Node 1 goes down, the entire service will be affected. So let's change the availability of Node 2 and Node 3 back to active. We can also disable scheduling pods on Node 1. Then if we redeploy the application, the pods will be deployed on Node 2 and Node 3. This is actually the preferred method in Kubernetes, to use the control plane only for managing the pods and deploy the workload only on the worker nodes. For now, let me change Node 1's availability to active again. Since we had pods already running on Node 1, so we drained a node, but normally we can disable scheduling pods using this taints option. For now, I will just update this node. Now let's see how easy it is to scale up in Kubernetes. All we have to do is edit the application again and increase the instance count. I will set it to 10 this time. And click on the Update Application button. Once done, Kubernetes will automatically create 10 replicas of our web server. That's how easy it is to scale up applications with Kubernetes. And we can increase or decrease the number of replica anytime just by modifying the instance count. Also, you don't need to worry about managing this service on other devices because Kubernetes takes care of everything. So in this video, we have managed an entire Kubernetes node cluster. Deployed applications, scaled up to 3 nodes, and managed the nodes right from the Portainer UI without ever touching the terminal. Portainer really simplifies Kubernetes, making it easier and even enjoyable to manage. So if you have been avoiding Kubernetes because of its complexities, maybe it's time to give Portainer a shot. In future videos, we will dive deeper into other components of Kubernetes with Portainer in a very simple way. If you like this video, don't miss the next one. Thanks for watching.